Today we are going to learn whether an equation is a linear equation or a nonlinear equation. You should be on pages 62 through 63 in your notes packet. Before we begin, we want to talk about what it means for something to be linear and what it means for it to be nonlinear. It's actually very simple. If we look at the word linear, it has the root word of line in it. A linear equation is something that creates a line. If we have something that is considered non-linear, then it is something that is not a line. So this can be a curve or something like that. Linear functions are always in the form y equals mx plus b. But what does that mean? Well, when we have the formula y equals mx plus b, y and x stand for the x value and the y value in an ordered pair for the equation. M represents slope. Remember that slope is another word for rate of change. B represents the y-intercept, or that is another word for what we have also called the initial value. That is where x is 0, and it is where your line intersects the y-axis. To determine whether you have a linear equation or a nonlinear equation, all you have to do is look at your x and your y values. If you have an x and a y in your equation that has an exponent of 1, then you have a linear equation. Nonlinear equations will have x or y values that have exponents other than 1, or an x or y value that is in a radical symbol, or an x or y value that is in absolute value signs. Let's look at your first 4 examples. Your first example says y equals 3x minus 2. I know that this is linear. I know that this is linear because this has a slope of 3 and a y-intercept of not 2, but because that's minus 2, it has a y-intercept of negative 2. So I'm going to say that I know that this has a slope of 3 because that's the coefficient of x, and that it has a y-intercept of negative 2. That means it will intersect the y-axis at negative 2. Now, I can figure out what I would put in here. If we think about this and we make a table, I can make a table with several x and y values. And all I would need to do is plug these in. So I'm going to just randomly choose x values. And like I've told you before, I like to choose a variety of negative and positive values. And I always choose a 0 as an x value so I can always find my y-intercept. So what I will do is plug these into my equation, which is y equals 3x minus 2. Since my first x value is negative 2, I'm going to say 3 times negative 2, which is negative 6. Then negative 6 minus 2, which is negative 8. Now I'm going to do the same thing with x is negative 1. I'm going to do 3 times x, but x is negative 1, so I'm going to do 3 times negative 1, which is negative 3. Then negative 3 minus 2 is negative 5. Then I'm going to do 0. 3 times 0 is 0, and then 0 minus 2 is negative 2. Next, I have x is 1. So 3 times 1 is 3, and 3 minus 2 is positive 1. Then I have x is 2. 3 times 2 is 6, and 6 minus 2 is 4. I can take these and place them on my coordinate plane. So my first set of values is that x is negative 2 and y is negative 8. If x is negative 2, I would move 2 left on my x-axis and then down 8. So if I move down 8 on this one, I notice that I have to go off of my coordinate plane a little bit. When x is negative 1, y is negative 5. So I would go left 1 for negative 1 for x, and then down 5. When x is 0, y is -2. Since x is 0, I'm not going to move left or right. But since y is -2, I'm going to move down 2 units. When x is 1, y is also 1. So I would move right 1 and then up 1. When x is 2, y is 4. So from the origin, I would move right 2 and then up 4. And you'll notice that if I were to connect this, I would get a straight line. So if we connect our points, we get a straight line that goes from one point to the other. So we know that this is a linear equation. Number 2 says y equals 1/2 x plus 3. Well, for this equation, we see that we have a number being multiplied by x and we have adding 3. So that means that for this equation, we have a slope of 1/2, since that's always the number multiplied by your x. And we have a y-intercept, or an initial value, of +3. And I know that it's positive because this says plus 3. Now, for me to figure out what goes here, we can make a table of values. I know that I'm multiplying everything by 1/2, all of my x values, so it might be useful if I use even numbers for all of my x values. Well, if x is -4, I'm going to say 1/2 times -4. 1/2 times -4 gives me -2. Then I would do -2 plus +3, which gives me +1. When x is -2, I'm going to say 1/2 times -2, which gives me -1. -1 plus +3 is +2. When x is 0, I'm going to say 1/2 times 0, which is 0, plus 3 gives me 3. When x is 2, 1/2 times 2 is 1, and 1 plus 3 is 4. When x is 4, 1/2 times 4 is 2, and 2 plus 3 is 5. So now I can plot all of these on my coordinate plane. When x is -4, y is +1. So from my from my origin, I would move left 4 and then up 1. Then when x is -2, y is +2. So I would move left 2 and then up 2. When x is 0, y is 3. So I would not move left or right, but I would move up 3. When x is 2, y is +4. So I would move right 2 and then up 4. And when x is 4, y is 5. So I would move right 4 and then up 5. And you see that if we connect these points, we are going to make a straight line. So we know that this is a linear equation. For number 3, we see y equals -2x plus 4. Well, this is also in the form y equals a number times x plus another number. So we know that this is going to be a linear equation. Our slope is the number being multiplied by x. So our slope is -2. Our y-intercept is the number being added here. So this is +4, which means it is a +4. Now we can take this and make a table of values so that we can figure out what to plot on our coordinate plane. Well, again, I'm just going to choose several x values, some positives, some negatives, always use a 0 somewhere. If I do -2 as my x value, then I'm going to do -2 times -2, which is +4. Then 4 plus 4 gives me 8. If -1 is my x value, I'm going to do -2 times -1, which is +2. 2 plus 4 gives us 6. When x is 0, I'm going to do -2 times 0, which is just 0. And then 0 plus 4 gives us 4. When x is 1, I'm going to do -2 times +1, which is -2. And then -2 plus 4 also gives us +2. When x is 2, I'm going to do -2 times +2, which is -4. If I do -4 plus +4, I get 0. Now we can plot all of this on our coordinate plane. When x is negative 2, y is positive 8. So I would go left 2 and then up 8. And of course, that would go off of my grid. When x is negative 1, y is 6. So I would move left 1 and then up 6 units. When x is 0, y is 4. So I would not move left or right since x is 0, but I would move up 4 since y is positive 4. When x is 1, y is 2. So right 1 and then up 2. When x is 2, y is 0. So I would move right 2, but then I would not move up or down since y is 0. And you notice that again, if I were to connect these points, I would have a straight line. So we know that this is a linear equation. For y equals x minus 3. Again, I know that this is linear because there's a number being multiplied by x. I don't see a number, but that doesn't mean that one doesn't exist. Because remember that when there is not a number in front of a variable, there is always an invisible 1. So if I were looking for the slope, I know that the slope is that invisible 1. If I'm looking for the y-intercept, it's this number at the end, which is not 3, but it is actually minus 3, which makes it a negative 3 for my y-intercept. So again, I can make a table of values, and I can put in several negative values and several positive values plus 0. Now to plug in this, when x is negative 2, I'm just going to say negative 2 minus 3. Well, negative 2 minus 3 is negative 5. When x is negative 1, negative 1 minus 3 is negative 4. When x is 0, 0 minus 3 is negative 3. When x is 1, 1 minus 3 is negative 2. And when x is 2, 2 minus 3 is negative 1. Now I can put this on my coordinate plane. So when x is negative 2, y is negative 5. That means I would move left 2 and then down 5 since my y values are negative. When x is negative 1, y is negative 4. So I would move left 1 and then down 4. When x is 0, y is negative 3. So I would not move left or right, but I would move down 3. When x is 1, y is negative 2. So I would move right 1 and then down 2. When x is 2, y is negative 1. So I would move right 2 and then down 1. And you can see that if we were to connect these points, we would have a line. Number 5 says that the temperature at dawn was 52 degrees Fahrenheit and increased steadily 3 degrees Fahrenheit every hour. So let's write an equation and graph the relationship. Well, let's think about what is happening. We know that the initial value is 52 degrees. So the initial value is another word for your y-intercept. And we notice that the rate of change is that it is increasing by 3 degrees every hour. So this would be our rate of change, which is another word for slope. So since this is our slope, we know that it's going to be the slope times x, so 3 times x. And I'm using a positive 3 because this was increasing by 3 degrees. If this had been decreasing by 3 degrees, I actually would have used a negative 3 for that instead. Now, since the temperature was 52 degrees and that is above 0, I know that's a positive, so I'm going to put plus 52 for my y-intercept. Now we can just plug in this information on our graph. So you notice that this does not have negative values because we don't measure time in negatives. So for this one, I'm going to start with 0, and then I'm just going to put some points past that. If I do 3 times 0, that's 0. Then 0 plus 52 gives me 52. 3 times 1 is 3, and 3 plus 52 is 55. Then I have an x value of 2, so 3 times 2 is 6, and 6 plus 52 is 58. Now I have an x value of 3. 3 times 3 is 9, and 9 plus 52 is 61. And then I have an x value of 4. 3 times 4 is 12, and 12 plus 52 is 64. So if I put this on my graph, I know that when x is 0, y is 52, so I would go up to approximately where 52 would be on my graph. When x is 1, y is 52 or 55. Well, you notice that this goes from 0 to 2, but there's space in between, which means I know that this is actually 1. So 1 is here, and then I would go up to 55. Well, 55 is right here, halfway between 50 and 60. When x is 2, y is 58. So I'll go to 2 and then go up to approximately 58. When x is 3, y is 61. So 3 and then 61. And when x is 4, y is 64. So up to 4 and then approximately 64. You notice that this would create a straight line. I know that it's linear just by looking at my equation because it's a number times x plus my y-intercept. So we know that this would make a linear equation. Now let's look at some examples that would not be linear. You can see in number 6, we know that this would not be linear. So we automatically know that it is nonlinear, but we can see this because our variable of x has an exponent of 2. And when we have exponents on our y or x that is not 1, we know that it's going to create something that is nonlinear. So for this, I'm going to put x here and y here, and I'm going to do my rule x squared plus 1 over here. So let's again choose some negative values and some positive values, and let's plug them in and see what happens. Well, -2 would go into this. Now remember, this says -2 to the second power. So I would say -2 to the second power plus 1. Well, -2 to the second power means -2 times -2, then plus 1. Well, -2 times -2 is 4, and 4 plus 1 gives us 5. So when x is -2, y is 5. When x is -1, I'm going to plug in -1. Well, -1 times -1 is +1, and +1 plus 1 is 2. Then I have 0, so this is going to be 0 to the second power plus 1. Well, that means 0 times 0, which is just 0, plus 1 gives us 1. When x is 1, I'm going to have 1 to the second power plus 1. Well, that means 1 times 1, which is just 1, plus 1 gives us 2. When x is 2, I'm going to have 2 to the second power plus 1. Well, 2 to the second power means 2 times 2, which is 4, and 4 plus 1 is 5. So let's see why this makes a nonlinear equation. We know that when x is -2, y is 5, so I'm going to go left 2 and then up 5. Then we know that when x is -1, y is 2, so I'm going to go left 1 and up 2. When x is 0, y is 1, so I'm not going to go left or right, but then I'm going to go up 1. When x is 1, y is 2, so that's right 1 and then up 2. When x is 2, y is 5, so that's right 2, up 5. So you notice that this actually creates what we call a parabola, where this is going up and out in both directions. Now let's look at number 7. So again, we have an equation that is nonlinear, and we can tell without doing the work that this is nonlinear because of this exponent of 3 on x. So we're just going to look at what this would look like on our actual graph here. So let's do -1 because -2 will go too far off our page. All right, so if we do -1 to the third power, then -2. Remember, -1 to the third power is going to mean -1 times itself 3 times. Well, -1 times -1 is +1. Then +1 times -1 is -1. Now, then I still have to do -2. -1 minus 2 gives us -3. Then I have 0 to the third power, -2. Well, that's just 0 times 0 times 0, which is still 0. And then 0 minus 2 is -2. Then we have 1 to the third power -2. Well, 1 times 1 times 1 is just 1, and 1 minus 2 is -1. Then we have 2 to the third power minus 2. Well, 2 to the third power means 2 times 2 times 2, which is 8. And then 8 minus 2 gives us 6. So if we plot this, let's look at what happens. When x is -1, y is -3. So that's left 1 and then down 3. When x is 0, y is -2. So that's not left or right, but then down 2. When x is 1, y is -1. So that's right 1 and down 1. Now, if you look at it right here, hey, that looks like it's a line. Why would this not be a line? But if you continue in either direction, when x is 2, y is 6. Well, that's right 2 and then up 6. Well, all of a sudden, you see that you had something that looked like a line, but then you've got to go up to get to this point. So you see that to get there, it has to curve. So we know that this would be nonlinear because, again, anytime you see an exponent on your x or y value that's not 1, which means that basically if there's an exponent that you see, this is going to be a nonlinear equation. Number 8, a square tile has a side length of x inches, and the equation y equals x squared gives the area of the tile in square inches. Graph the relationship between the side of the square and its area below. Well, we know that if we have an x here, we're using the equation y equals x to the second power to get our y value. Well, we know that we cannot have side lengths on a square that are actually negative values because we cannot measure anything as negative. So instead, we'll just start with some positive values. Well, since y is just x squared, we're going to say whatever x is to the second power. Well, 0 to the second power means 0 times 0, which is just 0. 1 to the second power is 1 times 1, which is just 1. 2 to the second power is 2 times 2, which is 4. 3 to the second power is 3 times 3, which is 9. And 4 to the second power is 4 times 4, which is 16. Well, if we plug these in, 0, 0 would be here. 1, 1 would be approximately here because we see that this is going up. It goes up by 4s, but each one of these is actually going up by 2s. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So since we're looking for 1 right here, we know that 1 is directly in the middle of 0 and 2, so it's going to be right here. Next, we have 2, 4, so we would go to 2 and then up to 4. Then we have 3, 9, so we would go to 3 and then up to 9, which would be right here in between 8 and 10. Then we have 4 and 16, so that would be right 4 and then up to 16. Now, it looks like it could be close to a straight line, but it doesn't go up at the same rate. So to get to all of these points, you actually do have to curve every time. So that makes this a nonlinear equation, which you know because this exponent of 2 right here tells you that this would be nonlinear.